Hello everyone. In the last lesson we installed WAMP server and we started looking at the PHP language and form submission using different methods. This video will focus on offering an introduction to databases using the MySQL language. Later in the series we will see how to connect PHP to MySQL database to add some data functionalities to our website. First, MySQL is one of the many flavors of the SQL language, which stands for Structured Query Language. Once you know MySQL, you can easily adapt to other languages such as SQL Server or even Oracle. It allows you to perform all of the basic operations on a database, that is, create entries, read from them, perform updates, and delete entries. We often use the acronym CRUD to describe those transactions. Let's see examples of some queries that read from a database. First, make sure your WAMP is running by looking in the taskbar. You should see a green W icon. If that's not the case, open the Start menu and type WAMP. You should see an option such as WAMP Server 64. Click on it to start your server. Once WAMP is running, open any web browser and navigate to localhost. You'll see a link that says phpMyAdmin. This is sort of an editor that allows you to manage your databases. Here I'm using a simple employee database, which you can find in the description below. I'm writing a query that is going to select all employees from the database. Select star from employees. If I run this query, we can see that we're getting the list ordered by employee number. Let's say we wanted to order it by last name and first name. We would do this by adding the statement order by last name, comma, first name. Now we can see that the list is ordered as instructed. Suppose we wanted a list of only the male employees. This would be done using a where clause. Where gender equals M. We can further specify that we want to see the employees hired after 2015. We build upon the where clause by adding and hire date is greater or equal to 2015 0101. For employees hired after 2015 and born after 1985, we simply add and birth date is greater or equal to 1985 0101. Now we can see that this is narrowing down the results. We got 150 results as opposed to the tens of thousands that we were getting with the previous queries. Another example is if we want the number of employees. We would do that using the count function. So instead of select star, we go select count star from employees. We can see that this is a pretty big database with over 300,000 employees. We could limit the search by doing something like looking up the employees that were hired in 2010, where year hire date equals 2010. This gives us around 25,000 results. Now let's say we would like the number of hires for each year. First, we would add the year in the list of fields to be selected. Then group the results by year. Group by year hire date. You can also order by year, let's say in descending order. Order by year descending. We're now getting the list, however the headers are not very user-friendly. They're saying year hire date and count. You can rename them using aliases with the keyword as, followed by the column name between quotation marks, as year of hire, as number of hires. Now the columns are named year of hire and number of hires. We can also see that the database contains other tables besides the employee table. We have one for departments, salaries, and titles. In fact, MySQL databases are what we call relational, meaning the different tables have relations between each other. Oftentimes we design a database using a diagram such as this one. Here we can see that each table is linked to the employee table through the employee number. For example, if an employee is a manager in a certain department, his number will be found in the department manager table, along with the department number. Same goes for the salaries table, for example. Each entry has a different combination of employee number and starting date. That entry will also include details about the actual salary, that is the amount and the ending date. Inside of a query, we can consider more than one table by using the join instruction. Let's say we reuse our query from earlier and we want to further narrow the results by filtering on the salaries. First, we join the salary table by using join salaries. Then we need to specify the joining condition. Here we want the employee number to be the same in both tables. On employees.employee number equals salaries.employee number. If we run this query, this is going to return all columns from both tables, meaning for each entry from the employees table, we're also getting the salary information. To limit the results, we can use a condition like salary is greater or equal to 60,000. Note that we're getting the history for each employee, so if their salary increased over time, we'll find more than one line for each employee. There's a way we can select only the max salary for each employee. First, we're going to specify the fields we want to include. First name, last name, and hire date. For the salary, we're going to use max salary. With the max function, we also need to add a grouping like we did earlier with the hire dates. Group by first name, last name, and hire date. And there we have it. Each line shows the employee and the highest salary that he's been earning. The possibilities are endless. At this point, you may be able to think of other examples, such as comparing departments by average salary, by salary increases, by number of employees, analyzing salaries versus seniority, and so on. Let's explore, for example, the departments. Select star from departments. Let's say we want to know the average salary for each department. We need to somehow reach the salaries table. But as we can see from the diagram, that table is not linked to the departments. That means we need to go through the employees table and then we have access to the salaries. We're going to have 3 join instructions. By the way, we can join tables easier by using aliases. Departments D, join department employee, which is the table that links employees to departments, on D dot department number equals DE dot department number, join employees E on DE dot employee number equals employee dot employee number, join salaries S on E dot employee number equals salaries employee number. Then group and order by department name. Now that we have this, we can select the department name and the average salary. Select department name, average salary. Another useful keyword that we might want to use in our queries is the distinct keyword. As we could see earlier when selecting employees, many had the same last name. Let's do select star from employees, order by last name. If we wanted a list of distinct last names, we would say select distinct last name from employees. Earlier we saw that the total number of employees was over 300,000. However, if we use count in combination with distinct, count distinct last name, we can see that there's actually 1,637 distinct last names in this sample database. So far we've been testing select statements. However, there's more to MySQL than just selecting data. We have the insert statement, which allows to create new entries in the database. For example, let's quickly create a new employee. The syntax is insert into the name of the table, in this case employees. Then between parentheses we list different fields we want to specify: employee number, birth date, first name, last name, gender, and hire date. Next is values with parentheses and the values corresponding to the fields we just listed. Let's say 500, 234, 1988, 01, 18, Clyde, Smith, M, and the hire date 2022-0501. We run the command and we can see that the line was added. And now we can perform another select from employees, order by employee number descending. We can see that the new employee was inserted in the database. We could further populate the tables by linking the employee to a department, specifying his salary, and so on. The question is, what would happen if we tried to insert an employee with a number that already belongs to someone? Let's use, for example, the employee number 20,000. We're getting an error that says the value is already used. That is because when the database was created, the employee number was specified as unique. This is one of the mechanisms that are found in SQL to ensure data integrity. With this, we have covered a lot of the basics on MySQL queries. As always, you're encouraged to continue your learning journey using resources such as W3Schools, which has an entire section dedicated to SQL. You can find the link in the video's description. In the next video, we'll start making the connection between PHP and MySQL by creating a simple crude web application that will allow us to perform transactions on a database. Thank you for watching and see you in the next lesson.